Hi everyone. Just Thank you very much for the followers and for subscribing my channel. So as I said in previous video, I'm going to do the series which makes you help to solve the problems in the physics for particularly for the AP 10th standard SSC, right? So to see the response I have posted the previous video. Now let's get start from this lesson, right? From this video, right? The first chapter is heat. We know very well the first chapter is heat. Now let's have the keywords, definition of the keywords, right? First of all, heat is a form of energy that always transits from a body at high temperature to the body at a low temperature, and the SI units of heat is joules and the CGS units are calories, right? Now let's see the definition of calorie. We know very well 1 calorie is equals to 4.186 joules. Now let's see what is 1 calorie. I mean 1 calorie in the sense how much energy it would be, right? So now let us see the definition. Just take a bowl, take a beaker. In the beaker take 1 gram of water, right? And it's at 28 degrees Celsius. Now here what you have to do is, let us try to increase the temperature of this 1 gram of water, right? So for example, let us try to increase the temperature of this 1 gram of water to 29 degrees Celsius, right? So here if you want to increase the temperature of this 1 gram of water, what we have to do, we have to give certain heat energy, right? Here the required heat energy to raise the temperature of 1 gram of water by 1 degree Celsius is called 1 calorie of heat energy, right? So here to define the heat energy, I mean calorie, why we are considering only water? Why don't we take some other substance? Because water is universal substance, right? So and universal solvent also, and none, it is available to everyone, right? That is the main reason of it. And next, coming to some other word, temperature. I told you when I'm telling the definition of heat, heat is a form of energy that always transfers from high temperature body to the low temperature body, isn't it? So now here, what is the meaning of temperature? Temperature in the sense the degrees of hotness or coldness of an object is called temperature. That means the temperature gives the information how hotter an object is, or else how colder an object is, right? So when I say 80 degrees Celsius an object, right? An object is at 80 degrees Celsius. Can you touch it? No, absolutely we don't, because we know an idea how much heat energy it has, right? So here the temperature gives the idea that how much hotter or colder. At the same time, it gives the direction to the heat flowing, right? So I told you in the definition of heat, always transfers from high temperature body to low temperature body, right? So coming to the units of temperature, the units of temperature, first in let us see in degrees Celsius, I mean Celsius. CGS units are degree Celsius and SI units are Kelvin, right? So of course there are many scales are there to measure the temperature, like Fahrenheit, Ramer scale. All those you might learn in the 9th class, but in 10th standard they may not ask all those. Only they ask you regarding degree Celsius and Kelvin. Here it is very important to know the conversion of temperature from degree Celsius to Kelvin and Kelvin to degree Celsius, right? So here do remember that when they ask you temperature convert into kelvins from degree Celsius, you must add 273. Actually we have here 273.5 or 0.15, but 273 is enough approximate. So now here for example, let's convert a 27 degrees Celsius into Kelvin, right? So if they ask you convert 27 degrees Celsius into Kelvin, what we have to do, we have to add 273, then you will get 273, then you will get 300 kelvins. That means 300 kelvins are equal to 27 degrees Celsius. In Kelvin scale it is 300 Kelvin, right? So what we are doing, when we want to convert degrees Celsius into Kelvin, we have to add a 273. In the same manner, when we want convert 330 kelvins into degree Celsius, we have to subtract 273, right? A 7 here and 5 here. 57 degree Celsius. That means 330 kelvins are equal to 57 degree Celsius. This is the conversion of temperature. And one more be a good question from the temperature, they may ask you that there are two blocks which are made up of iron and wood, and we have kept them in the fridge for the same amount of time. After certain time, just we have removed from the fridge. Now if you touch with your both hands, you feel iron block would be cooler than that of wooden block. What would be the reason, and why do you feel like that? So here absolutely we feel iron block is cooler than that of wooden block, but the reason is here the degrees of coolness of the wooden block is greater than that of, sorry, the degrees of coolness of the iron block is greater than that of wooden block. That means when you touch wooden block and iron block at a time, that heat energy that flowing from your body to the object, like to the iron, is greater than that of the heat energy that traveling from your hand to the wooden is greater, right, than wooden, like, right, understood? So what we can do, let me tell you once again. When you touch an object, then what happens? Absolutely, heat energy may flow into our body, or from our body to the object it flows, right? Here, when the heat energy lost by our body, we feel cooler. When the heat energy gained by our body, we feel hotter, right? So when you touch both of them, that heat energy transferring from your body to the iron body is greater than that of the heat energy that traveling from your body to wooden block, right? This is the reason when you touch both of them, you feel more cooler to the iron block, right? So next, one more thing that we have to discuss here: thermal equilibrium. Thermal equilibrium in the sense, when you two objects in thermal contact, then heat energy will flow from high temperature body to the low temperature body until both of them gain the same level of heat energy, right? So here, after gaining the same temperature or same heat energy, the flow of heat will be stopped, right? After gaining the same temperature, the flow of heat will transfer stops from one body to another body, right? Exactly, this situation is called thermal equilibrium, right? This is about the thermal equilibrium. And next, the main important thing is kinetic energy of the particles. Every substance is made up of molecules. Molecules are made up of atoms. Finally what I can tell is a substance is made up of particles, right? Here, if the temperature, absolute temperature is more to the any substance, then its average kinetic energy also will be more. If the temperature of the substance is less, it means that the average kinetic energy of the substance also will be less, right? And after this, one more important phenomena in this chapter is principle of method of mixture, right? So what is principle of method of mixture? When you when you contact two objects, thermally contact two objects, right? Here the heat energy lost by the hotter body will be heat energy gained by the cooler body. When you bring out few objects in a thermal contact, then what happens? In the few objects, hotter bodies will lose heat energy, cooler bodies will gain heat energy, right? Here the net heat energy lost by the hotter body will be equal to the net heat energy gained by the cooler body, right? So now here, let us use this principle and derive the equation for the final temperature of the mixtures, right? So before using this, let us derive the equation for the heat energy, right? So here, to derive the heat energy for the equation for the heat energy, what we have to do is, first let's take two situations. The first one is which tells you the heat energy is directly proportional to its mass. Let me tell you a very simple. For example, if you want to cook food for two members, so to cook food for two members, it takes very less time, isn't it? And it takes very less heat energy. If you want to cook for 10 members, obviously we have to use more ingredients. When the mass increases, the required heat energy also increases, so it takes long time to cook it. That means it takes more heat energy. That means uh, q is directly proportional to mass of the substance. Q is directly proportional to mass of the substance. right? So if we have more heat, I mean if you have more mass, to raise the temperature of more mass we require more amount of heat, isn't it? So now here in the same way, just you take a bowl, right? Take two bowls. Just think, in this we have taken a same substance for 1 kg, in this we have taken same substance for 2 kg. Here it's very clear that, let's imagine in the starting temperature of both substances are same, 26 degrees Celsius. Now if you raise the temperature to 50 degrees Celsius, what we have to do, we have to give more, I mean we have to give heat energy, right? Here in this scenario you have to give more heat energy to the substance which has 2 kgs to raise the temperature to 50 degrees Celsius, because the mass, as the mass is more, the required heat energy also will be more. So from this we can conclude that easily Q directly proportionals to M. Q directly proportions to mass of the substance. In the same way, let's do one more same experiment with, take the same bowl, say single bowl with, let's take 2 kg of substance at a 26 degrees Celsius. Now if you want, if you give the heat energy continuously, then what happens, the temperature increases continuously. For example, if you start giving heat energy, the temperature increases to 30 degrees Celsius. If you keep on giving the temperature, the, I mean heat energy, then the temperature also continues increases, right? Here from this experiment we can tell that the heat energy, if you give heat energy continuously, the change in the temperature also changes continuously, right? That means from this we can tell that the given heat energy is directly proportional to change in its temperature. It means if you give more heat energy, there will be more change in the temperature, right? So from these two experiments we can conclude that Q directly proportions to M into delta T. If you want to remove this proportionality, you have to write is equals to, and we have to multiply with some proportionality constant and M delta T. Here this S is called specific heat of the substance. S is called specific heat of the substance, M is called mass of the substance, and delta T in the sense change in temperature. Change in temperature. Q is equals to Sm delta T, right? So now here this is a formula where we use to calculate the gained heat energy or lost heat energy or released heat energy of any substance, right? So this is the main formula from the heat lesson. Now by using this formula, which formula Q is equals to Sm delta T, we are going to find the final temperature of the given mixture, right? Let's assume that, I mean for this we use the principle of method of mixture. What is the principle of method of mixture? When few objects are in thermal contact, then what happens, the heat energy lost by the hotter bodies will be equal to the heat energy gained by the cooler bodies, right? So now here let's see, let's take a first beaker. In this beaker there is a substance which has mass M1 and specific heat S1 and at the temperature of T1, and another beaker with mass M2 and specific heat S2 and the temperature will be T2. And let's imagine that T1 is at high temperature and T2 is low temperature, right? So what happens when you mix both of them? Obviously heat will transform high temperature body to the low temperature body, right? So now here when you mix both of them, what would be the final temperature? M1 plus M2. What about, I mean sorry, the final mass is M1 plus M2. What about the final temperature? It is not like mass, right? We cannot add T1 plus T2, right? Just imagine when you are going for both hot water, if the water is too hot, you will add cool water to decrease the temperature of hot water, isn't it? In the same way, the final temperature definitely not greater than that of T1, because T1 is a hotter body, right? The final temperature, let's imagine the final temperature as a capital T, so caps T, right? So this final temperature is not greater than that of T1 or not less than that of T2, right? So we have to calculate that, right? Now let us see, when you mix both of them, then we know that the hotter body will lose the heat energy and the cooler body will gain the heat energy, right? According to the principle of method of mixtures, the heat energy lost by the hotter body will be equal to heat energy gained by the cooler body, right? So that means QL, heat energy lost by the hotter body. So what is the formula? Q is equals to Sm delta T, right? So QL is equals to specific heat of the hotter body, mass of the hotter body, and change in temperature. Delta T in the sense change in temperature of the hotter body. Actually initially the temperature is more and it decreased to T. So this is the change in temperature. In the same way, heat energy gained by the cooler body, that is be equal to specific heat of the cooler body, mass of the cooler body, change in temperature. Initially the cooler body at low temperature, after mixing with the hotter body, the temperature gets increased. That means T minus T2, right? According to the principle of method of mixture, QL will be equal to QG, right? So now here, what is QL? QL in the sense S1 M1 T1 minus T, that is equals to QG in the sense S2 M2 T minus T2, right? Now S1 M1 T1 minus S1 M1 T, that is equals to S2 M2 T minus S2 M2 T2, right? Now we have to calculate what is our target in this experiment, to find out the final temperature of the given mixture, right? So now take this T to one side. Sorry, no need to bracket here, right? Yeah, let's take this, right? Now what happens? S1 M1 T1, take this term to this side, plus S2 M2 T2, that is equals to S2 M2 T plus S1 M1 T, right? So here S1 M1 T1 plus S2 M2 T2 is equals to, take T as a common, S2 M2 plus S1 M1, right? Now let's take we have to calculate this, right? We have to find out the final temperature. That means we have to send this term to this side. Now let me rub the board and do it here. Okay, I can do here, right? So now here final temperature will be T is equals to S1 M1 T1 plus S2 M2 T2 by S1 M1 plus S2 M2, S1 M1 plus S2 M2, right? This is the formula for the final temperature of the given mixture. Here, if these two are different substances, then we have to use values of S1 and S2. No issues, it would be not in the 10th standard syllabus, but in case if they ask, then you have to use this formula. If the both are same substances, then S1 S2 will be similar. So that what happens, final temperature is if you can take S and S, S1 is equals to S2, that is equals to S, because if both are similar substances, their specific heat values will be same. So that if you take S as a common, then M1 T1 plus M2 T2 by, here also you can take it as S common, M1 plus M2. Now S gets cancelled. Now final temperature will be T is equals to M1 T1 plus M2 T2 by M1 plus M2. By using this formula, you can calculate the final temperature of the given mixture. This is about the principle of method of mixture. Let's recall once again.